Hello, everybody. Welcome to Chloethedev Unfiltered. I was actually gonna go through a paper from the Consensus Diligence 45th newsletter, and yes, I have on my unicorn onesie. It's Halloween, don't you know? Halloween, don't you know? So today I'm just going to be going through some NEAR information, though. I was talking to the head of education at NEAR, um, and he sent me over some information to start going through. I didn't say thank you yet, so I should probably do that. But I decided I'm just going to jump right into it, go through this basic document first, and then he sent me this lunch and learn, where you go through. There are 7 episodes. I know I say episode weird. And you go through like cross shard transactions, economics in a sharded blockchain. And so, honestly, Ethereum 2 is going to be using shards eventually. And so I know there's differences between Ethereum and NEAR, and I have not looked into it nearly enough. So for me, this is the time for me to dig into what makes NEAR tick, what makes it different, what makes it unique, what makes it the same as Ethereum, what makes it different than Ethereum, what makes it similar to Ethereum 2, what makes it different. I know it's proof of stake, and I know things are slowly progressing into a full blockchain. They're listed on a few exchanges now and such. But yeah, I have no clue what to expect. So I'm just going to start digging in. So, new to NEAR? Yes, I am new to NEAR. They have a little orientation that is super cute. So welcome. This page will give you a single guided path through the experience of getting to know the NEAR platform. That's awesome. If you have any questions on the way, we have a vibrant community in the Discord that is eager to help. That is also great. I hate Discord though. I'm sorry. I will jump in. I need to go through my Discords and delete a bunch of them again and just start fresh with the ones that I'm interested in because there's too many these days. What is NEAR? NEAR Protocol, aka NEAR, is a decentralized platform where developers can host serverless applications and smart contracts which have easy access to open finance, DeFi, networks, and benefit from an ecosystem of open web components. Unlike other blockchain-based platforms, the NEAR protocol has been built from the ground up to be the easiest in the world for both developers and their end users, while still providing the scalability and security necessary to serve those users. Specifically, NEAR is designed to make it easier to build decentralized applications, especially as a developer familiar with only traditional web or app concepts. So that's great. Personally, when I started learning how to develop and do all this blockchain stuff, I had no background knowledge really in traditional web concepts. But I've already looked a little so the fact that NEAR uses ENS type names or human readable names or addresses has been helpful so far. Instead of all this hex stuff that you never see hex in traditional web servers, at least not with regular React development at least. Onboard users with a smooth experience, even if they aren't familiar with crypto, tokens, keys, wallets, or other traditional artifacts of this ecosystem. I have never tested out a NEAR wallet aside from what I use on my Ledger. It was pretty easy to use on my Ledger, but again, I would love to learn more about the onboarding experience for NEAR and scale your applications since the underlying platform automatically expands capacity via sharding without additional cost or effort on your part. So they're saying the network's scalable. There's always trade-offs with every network, though, so I'd love to see what the trade-offs are. So open finance networks facilitate digital value transfer and storage using tokens and tokenized assets. Particularly, this spans everything from easy peer-to-peer payments to sophisticated lending and trading protocols. Basically, DeFi. Open web components are reusable smart contracts. So basically, smart contract. I'm not going to read all that. What is a blockchain? So let's do how they define it. A blockchain is a particular kind of irreversible distributed ledger which combines aspects of both computation and data storage. Each new block which is added contains modifications to the state of the ledger that have been agreed upon by the consensus of the distributed nodes which run the network. These ledgers allow for a large number of participants to permissionlessly but collaboratively manage extremely large amounts of value. For example, Bitcoin, the Bitcoin network, is worth more than $100 billion, which is a lot of money. entirely through the use of basic economic incentives like mining and mining rewards and block subsidy, all that kind of fun stuff. While it is intellectually interesting to explore the theory and technology behind blockchain, is not necessary to do in order to build, test, and deploy apps, which is hilarious because I agree, but I've never really cared about this whole part: building, testing, and deploying apps. I'm much more interested in the whole intellectually interesting and stimulating theory and technology behind blockchains, but that's just me. Similarly, you don't need to understand how fault tolerant commodity compute clusters work inside AWS. All that sounds like so much fun too. GCP, which I guess is what Google or Microsoft Azure, in order to deploy an app to these clouds. Focus on the code. I'm the opposite of that. I focus on everything but the code. Code is just so repetitive and boring to me. I like reading. I like reading like good code, like easy to understand code. Like good, solid, logical code is good. But they got some like generic videos here. I'm not gonna watch. They have the beginner's guide to the near blockchain, which I might read. I don't know. Set up an account. Let's see. They're saying that I have to go to this and set up an account. If I wanted to create a brand new account, it looks like I just gotta click it and hit go. Only the testnet account can create accounts such as yourname.testnet. All accounts created in this wallet use the .testnet. To learn more. Okay. So this is using, okay, yeah, test only wallet. I have a real Near wallet, but I guess you can only use the test wallet here. I don't know. See, this is where I get okay, look, let's see. January 2019. I feel like that's old. That's old information. More about Near. Yeah, but give me some details. How do you make money? Near is on a company. Near is a collective. Their job is to do the research and development. That sounds like fun. One collective member worth noting is the Near Foundation, the nonprofit entity. Okay. Cool. I have not looked into Near for so long. I don't know. I haven't gone into it much. But I'm excited to see what's available. Oh, this stuff is too old, man. This stuff is too old. The Near white paper would be fun. Let's see. Ooh, they have the economics paper. The whiteboard series is very cool. Epicenter, Zero Knowledge. Man, Near's been doing so much. Oh yes, Vitalik's blog. I need to go through the blog more. Sorry, not right now, but okay. Honestly, that was enough information from that. The white paper. Near is a decentralized application platform. Honestly, I've read so many white papers in my life that I pretty much... Let's go to some fun stuff, like governance. Here's how Near's core design principles apply to governance. Ugh, not fun yet. Near's governance. It's just all like... you know what? This is why I was saying it might just be videos, because I want some substance. Developer business models. Transactions and storage fees. Oh, this is some fun. You have your any blockchain protocol validators provide their resources in exchange for a reward. These rewards are usually a combination of Coinbase and transaction fees. Ooh, in the Nightshade design, all the logic is done on an epoch level, and validators get elected and rotate. I should just read the Nightshade paper, probably, and add it to the consensus papers I've been going through. So let me try and find, honestly, just find the Nightshade paper. Blockchain resource pricing on the stability of Bitcoin without the block reward, staking and delegating in smart. There you go, Nightshade. Here we go. And I mean, the paper is probably too long for me to want to read right now. 40 pages, but I will go through this as my next paper because I don't think I'm following these people too on Twitter, but I should. Anyways, so that's what we're going to do tomorrow for our paper, last paper of the week. And I think for the rest of this video, newsletter, event, Stack Overflow. Yeah, this lunch and learn stuff looks really cool. So I'm just going to pop into these. I'm going to listen. And yeah, that's about it. So let's see. I'm going to turn on the subtitles. Hopefully that works well.
And I will use Nightshade, which is near-sharding design for the example.
So let me see if my volume's all the way up.
So in Nightshade, there's a main chain which produces blocks every.
So we're talking about how a Nightshade,
few seconds.
the main chain produces blocks every few seconds.
And each of those blocks for every shard contains 1 or 0 call them chunks. So for example, let's say there's exactly 4 shards.
So this will help me, and then when I actually go through the paper,
0 chunks for each shard. Those chunks, they build on top of the last chunk that was produced for that shard. And so effectively those chunks, they kind of represent a shard chain. Right, so this chunk in the first shard and the third block is building on top of the chunk that was included last time for the same shard.
interesting. Okay.
Yeah. Okay.
So each chunk is building upon the chunks from before.
This
Okay.
presentation, we will not look at the main chain blocks. We will just look at the shard chain and the chunks. And so the shard chains, they produce the shards, they produce chunks at some time intervals. And so time interval 0, time interval 1, time interval 2, etc.
Okay.
So what we want to happen is in an optimistic case where 2 shards do not skip chunks, which in reality is going to be the case most of the time, assuming that the uptime is efficient of the
Okay.
validators and they're not skipping bits. We want to achieve the following: that if a transaction that touches multiple shards arrives at certain heights, let's say at height 0 in one shard, so that's the transaction, then the receipt of the transaction, which effectively executes the second part of the transaction, arrives to the next shard at the very next block. That sounds like it should be very simple and doable, but there is a challenge. There is a problem, and the problem is the following.
Okay, what's the problem?
To understand the problem, let's first see how
Let me
blocks
first
are
see how
processed and
OBS
produced,
is looking.
and what is the actual timeline of
Oh,
producing.
see, yeah, my
Right, so
thing
if
is
you
too
draw,
big. No one needs to see me that big.
This axis is time, and we look at the blocks and what happens, and there's a particular moment in time, or other chunks, not blocks.
I'll just keep it like this.
When the chunk for shard 0 was produced. And then the question is whether the block producer or chunk producer who produced the chunk validated the transactions in the chunk before sending it out. And so, for example, in Bitcoin, if you produce a block, you do validate transactions before you send the block. It has a problem. It has a problem that if the block producer of chunk 0 validated transactions before and computed the new state before sending the chunk, then it means that any other chunk producer, so let's say chunk producer 1, they cannot start validating the same chunk before chunk producer of this chunk finish validating it, because it wasn't sent before it was validated. Right, and so these two events, the chunk producer validating a chunk and any other recipient in the system, any other validator, for example, chunk producer for the next height, validating the chunk, they end up being serialized one after another. But naturally, the chunk producer of shard 1 cannot produce chunk at height 1 until they validated the chunk at height 0.
So you're drawing, like, there are two shards there, right?
Oh, that's one shard and two chunk producers, sorry. So that's chunk producer 1. Chunk producer for height 0 and chunk producer for height 1. But it's within the same shard, right? So if you do validate transactions before you send out the chunk, what ends up happening is you create a chunk, you validate it, then you send it out. The next chunk producer has to receive it, validate it, before they can produce the next chunk.
Okay.
And then the same happens again, right? The 0th chunk producer receives the chunk, validates it before producing the next of their own. At height 2. Sorry, this is one.
Yeah, okay.
And so therefore, the validation happens serialized twice. And validation is actually pretty expensive. It may be not the biggest bottleneck in the system, but it does take time. And so that ideally should be removed. And so instead of that, Near and many other blockchains, but Near specifically, which is going to be relevant, operates in a different way where when you produce a chunk, you do very basic validation of transactions. Specifically, you only validate that the transaction issuer has money to cover the gas price. Accumulates transactions to the chunk and immediately broadcasts it. And that chunk is considered valid even if it has invalid transaction. Valid transaction just charges the gas but remains in the chunk. Right? And why it is important? It is important because the chunk producer, when they broadcast the chunk, they don't know the post-state root. They don't know the state root as of after applying the transactions.
Yeah.
So therefore, that post-state root cannot be stored in the chunk. And that also means that the receipts that are going to be produced as a result of applying this chunk, they are not included in the chunk as well. Right? So receipts will only be known when everybody else receives the chunk and processes it.
That makes
right?
sense. Then they can all
So
validate.
this is where the challenge happens, is that by the time, now let's consider another shard, right? So there's another chunk producer, let's call it chunk producer 2, and they're producing a different chunk shard. So that, so this is shard 0, let's call it S0, this is S1, also S0, and this is shard 1. So when they receive the chunk,
Jeez.
or like some information about chunk that was produced for the shard 0, they do not know yet. They don't know the receipts, but also they cannot apply it. Why? Because they don't see the full shard, the full chunk, in the sense that if there's 100 shards, it is infeasible for every chunk producer in every shard to send the full chunk to every other shard.
Okay, now I'm
So
confused.
effectively,
Okay, wait.
the chunk producer in shard 1,
Let me go back. What did you just say? I lost track of what was going
they
on.
don't know the receipts, but also they cannot apply it. Why? Because they don't see the full shard, the full chunk, in the sense that if there's 100 shards, it is infeasible for every chunk producer in every shard to send the full chunk to every other shard.
Yeah. They don't have the full view.
The chunk producer in shard 1 will not see the full chunk from shard 0. They cannot see the full chunk from every shard. So all that they receive is they receive some header and some information with it.
Yeah.
And so in particular, they cannot receive the receipts from this shard, but also they cannot reproduce the receipts because they cannot apply the chunk. They don't see the full chunk. Go ahead.
They don't even know whether this chunk is relevant to them, right?
They don't even know if it will have any. They do know if the chunk is relevant when the block is produced, like when the main chain block is produced. So this is the main chain block.
Okay, so we still have the main chain, like a beacon chain, I guess.
By the time they receive the main chain block, they know all the chunks which are included. So at least they know that the chunk is actually included on the main chain. And assuming
So they get a header.
you probably expect most of the shards sending receipts to most of the shards. So they know chunk is included. They sort of know that probably there are receipts coming from the chunk, but they don't know. What the receipts are, right? And so coming back to this picture, now that we discussed that problem, so what happens is in this shard, whomever is going to be producing this chunk, by the time they produce chunk, they have no way of knowing the receipts
From the
as
preview.
of applying this chunk, right? And that's the biggest problem. There's no way for us to do that. If we did go with the approach where the chunk is fully applied before it is sent, that problem would be solved, because then the chunk producer would have known the receipts as of applying the chunk, and so whatever message they're sending to the other shard, that message would just include the receipts. But again, that becomes significantly slower, right? Okay, so what can we do? We definitely cannot, without some magic, as we just discussed, we definitely cannot know the receipts by the time we're creating the chunk. But also we don't need to know the receipts by the time we're creating the chunk. We need to know the receipts by the time
We
we're
send.
executing it.
Yeah.
Right. So in reality, and so let's say this chunk produces chunk 1 for the shard 1, right? They don't need, and so later down the road someone else is applying it. In reality, we don't need to know the receipts at this point when we create the chunk.
You need to know when
We don't
you.
need to know the receipts
The
by the
end.
time we apply the chunk,
Yeah.
right?
So do some
Does that make sense?
finagling.
And so the way it is done today is the following. When a chunk producer, in this case one of the chunk producers of shard 0 produces the chunk, we already have to distribute small parts of the chunk to every block producer in every shard. This is how data availability in Ledger works, right? So when they do that, they also actually let's use one as an example. One is a better example.
Yo, I want to go through these more. These are so good.
The chunk producer
They're
created the chunk
complicated
one.
though.
The very last thing they did before that is they applied chunk 0. Right, so they received chunk 0, they had the state, they applied it, they know the new post state root, and they know all the new receipts. So when they create a new chunk at height 1, they do the following. First of all, the header of this chunk will contain pre-state root,
Okay.
which is the post state root for the previous chunk, but it will also include the receipt Merkle root of all the receipts produced as of after applying 0.
Yeah.
Right,
Okay.
so we don't know yet the receipts which will be produced after applying 1, but we do know receipts that will be produced after applying 0.
Just
So
doing
there's
things a little
Merkle root of all
backwards.
those receipts. And also those receipts are sorted by the destination shard ID, and so you can prove any subset of those receipts going to a single shard.
It's almost like you're doing the whole thing in ETH2 where you do finalization on a previous epoch.
Small pieces to send to every validator for data availability. Together with those little pieces, they also send all the receipts relevant to the particular block producer for their shard. Right. So when this little thingy goes to this chunk producer in the shard 1, all the receipts that go from shard 0 to shard 1 as of after applying this chunk, they will be included in the message.
When I draw an arrow like this, should it be going to chunk number 2 in shard? That's
Or like forward.
yes.
Uh,
I mean you're drawing it.
So in time, so like it will not get. Yeah, it will not get included into this chunk, right? Because this chunk and this chunk they produced concurrently.
Yes.
Right. So yeah, so you're right. So it goes like in time it will land around here, right? Now what's important is that when you
Makes
receive a
sense.
block, a particular block, and you see chunk headers in it, that block is considered orphaned until for every shard and for every chunk included, you either have the full chunk if that's some shard you validate, or you have this little one part if it's not a shard you validate. And there are protections in place which protect against lazy behavior, so you cannot pretend you know it. If you pretend you know it, there's a good chance you will be slashed. There's a protection in place. So you will not unorphan the block. You will not consider the block valid until you have those little one parts for every chunk that is included. And that also means that you have all the receipts for every shard. And those receipts are provable because there's a Merkle root here, right?
So basically you gotta do some
Header
validation.
is a block, and you have the Merkle proof against that.
All receipts of every
destination person with the part that goes to that person. Yes. Right. And so now, by the time I need to apply chunk one, I would only
It's
apply
not
chunk
bad.
one
Like
if I
4 minutes
see
left. I think I'm gonna do these one a day from
those
now on,
chunks.
for sure.
Well, unfortunately, I don't use the shard ID, right? So let's use.
Until I'm done this series, at least. I'm learning a good amount about Nightshade.
This is all this one.
Yeah, so maybe one of these videos a day,
Right. So
and then maybe I'll go through the Nightshade paper tomorrow, or start it tomorrow.
And this one. Right. So this is the chunk one for shard 0. This is chunk 1 for shard 1. I will only apply this chunk when I process this block. I only process this block if it is not an orphan. It is only not an orphan if I have one part for every chunk included, including the chunk 1 for shard 0. And so those.
So they're just going that every block is orphaned unless it's
We
validated.
guarantee that by the time you're applying chunk at height 1, you have all the receipts from all the chunks that are included at the same height.
Again, we apply block when we either have full chunk for each shard, or for some of them we have.
So I guess
one part.
Right. So
I don't think you get
block producer
a
uses
finality
some shards they care
guarantee,
about. That's the subset of shards that they validate.
but you'd always have
There's another subset of
justification.
shards who are larger,
I don't
who
know.
don't validate.
Seems very different.
You need the full chunk for every shard, you fully validate, and you need just one part with the receipts for the shards.
Like in Ethereum 2, I understand the security guarantees.
Either way, you
I need to read the
use
Nightshade paper so I understand the consensus guarantees of the blockchain, or else it's kind of confusing for me
then
still.
naturally you applied the previous chunk, so you have the receipts locally because you computed them, right? So either way you have all the receipts, and so that guarantees that gives you one block cross shard transactions, right? Oh, sorry, this is here because the receipt which was created as a result of applying this chunk will be processed already as of the time this chunk is applied. So there's exactly one block.
So one block cross shard transactions, meaning
And the same applies
okay.
if it sends a further cross-shard transaction, it will also be applied in the very next block. Moreover, we guarantee that receipts don't get lost. This is another problem that many blockchains face today, that the sharded blockchains, is that they don't have any guarantee that the receipts will be applied. Here, if the receipt is not sent, if it's not part of the Merkle proof, that's a slashable behavior because every other participant in the same shard chain, they will also apply this chunk. They will also get the receipts, they will also compute the Merkle proof. If the Merkle proof doesn't match the Merkle proof included in the header, that's easily provable cryptographically, and that's a slashable behavior.
How many
everybody
nodes does
arrives
Near
at the same
have?
proof. Every recipient and every other shard, they will check against the proof. They will know they have all the
This
receipts.
seems like a lot of
So
work
it's
to be
gonna
running on my computer at home.
delivery.
That's for sure.
And then the last problem, which we're not going to discuss very deeply today, is that there is a problem that if all the shards send receipts to a single shard, that will spam the shard, right? So we're not going to go very deep into that. But this is also partially solved because you can accumulate the receipts, but you don't have to apply all of them at once. You can put them into the queue, and then you just
You could have
process
a
the first
queue.
100 receipts that got into the queue.
So you could have a max number of one block cross shard transactions.
I think the only way to do that is to fail transactions if the queue is full.
Yeah, so if the queue's full, you fail transactions to the next block.
Destination queue for shard 1 is
Oh,
full.
wait.
You will fail any transaction that tries to go to shard 1. Cool.
Very
So
cool.
that covers the receipts. You have more questions? Awesome.
So, this guarantee, right? I mean, it basically allows you to say that your receipts are not lost when it's producible. When we either have the full chunk that we care about, or we have like one part of whatever we don't care about.
I like that I can hear the questions too.
Yes, that's correct.
It's supposed to be like this is what allows sharding because you care about all the small shards, right? And everything else you kind of don't care. So it's like a little bit the overhead. So I have a question on this actually a little bit of the overhead because
Okay.
we have a system where we have
Yeah, that's what I'm about.
and
The overhead.
other transactions are for short transactions. If let's say we have financial system, people just set it by each 100 shards.
Right.
I mean, most of the transactions are going to be cross shard transactions, which means like the content of the block for all the chunks.
And then that's a good thing. If you have a simple thing where people are sending transactions, the question is saying, okay, well, most transactions are going to be cross-shard transactions, but not necessarily. I mean, what you could do is you could have, you know, everyone who onboards comes into one main shard, and that's where all your main financial aspects are. And then you could have people opt in to these other shards where, you know, maybe computation is different, maybe cheaper, maybe faster, maybe less security, or whatever else. But do you need to have all the shards at the same capacity? Could you have some shards that are, or at least if you don't put everyone on one shard, that's kind of like the Ethereum ways to have, you know, everyone on one shard, and then maybe have like 3 or 4, you know, 6 shards, or you do, but maybe have shards that are more use case specific. So you have like, you know, a shard that people use when they're doing just low value transfers, a shard people are doing, maybe different parts of the world will use different shards. I'm not sure, but it's not necessarily a black and white.
Receipts, half transaction with just the right.
Right. The question is, do all of the receipts go to the same shard? Because this one part, it doesn't contain all the receipts. It only contains receipts which go to the shards that the receiving person cares about. Right?
Oh, I see. So basically, in this system, then it would be like if I care about one shard, then on average, all the receipts accumulated from all one part says I do not care about. I'm probably going to be on the same volume as
Yes.
transaction.
Yes. So if the system is not skewed, if it's well balanced, then you will be receiving as many receipts as you receive transactions, which is definitely viable. It is still a problem, though, that if you're in a shard that is super popular, you might be getting way too many receipts.
Yeah, if one shard's too popular, you want to move shards.
You can limit how many.
But this is like
do some constant, like, you know, three
it's like
years.
property. Certain shards will have certain popularity based on
Something like
who's
1
using
over
it.
number of shards multiplied by 3, something like that. More questions?
Good question.
Okay, so that covers our first lunch series. Thanks everyone for listening.
So yeah, that was the first one. I enjoyed it. I think I'm gonna just pop in and do those once a day. So that one was on cross shard transactions, and the next one is on economics in a sharded blockchain, and I'll go through that maybe later on today, but more probably I'll be going through this tomorrow. Thank you for everyone who may have watched. You know, feel free to watch yourself. I put the link for these videos in the bio. I'm just doing this for myself to learn a bit more about what Near's doing in different blockchains. I'll go through the Nightshade paper as well. I love going through consensus papers. But yeah, hope you all